Assalamualaikum warahmatullahi wabarakatuh. My name is Devin from F46 INT, and today we are going to presentate about me and Shafiq's group assignment 2 about probability theory. So in this experiment, we take the surveying Telkom University students about their motorcycle brand preferences or ownership. So the sample we took from this experiment are Aprilia, Benelli, BMW, Ducati, Harley-Davidson, Honda, Husqvarna, Indian, Kawasaki, KTM, Moto Guzzi, Royal Enfield, Suzuki, Triumph, Vespa, Yamaha, Don't Have, and Tsunami. These are the motorcycle brands we take from surveying Telkom University students. And the event we have from the sample are for event A is Honda motorcycle user. For event B is non-Honda motorcycle user. And for event C is no motorcycle ownership or they don't have a motorcycle. Okay, for the next part will be explained by Shafiq. And for Shafiq, time is yours.
So thank you for Devin for the time. So I'm gonna explain about the part of the D. So we compare the probability of the event of event A. As you can see in here, we define event A is Honda motorcycle user. In our data, event A has 7 out of 42 respondents. So this is equal to 0.766 and so on until 7. For the probability of event B, as you can see in the part of the C, B is a non-Honda motorcycle user. So the event is not a Honda motorcycle user, which is equal to 28 over 42. So it will be equal to 0.66 until 7. From the C, unfortunately, or identically, I think the event is similar with the A because the number of the Honda user and then the motorcycle ownership, which is the student who doesn't have a motorcycle, is the same. So I counted like the same 7 out of 42. So it's the same for the probability. And then move to the part E, define and the variable. So for the variable, we need to count the probability one by one for each motorcycle brand. For Aprilia, in our data survey, we have one respondent out of 42 respondents. So we divided by 1 divided by 42, so it's equal to 0.024. And then for Benelli, there's 2 respondents out of 42 respondents. So we divided by 2 divided by 42 is equal to 0.048. As you can see, BMW is the same with Benelli, so we have a respondent. And for Ducati as well, we have Harley as well, so we have 2 respondents each for each brand. For Benelli, BMW, Ducati, and Harley, we have 2 respondents out of 42. For Honda, we have 7 out of 42, so we divided 7 by 42. So the probability is 0.1667, yeah. And then for the Husqvarna, the same with Aprilia. We just have one respondent according to the survey. So the same value as Aprilia is it 0.024 and 0.024. It's the same. And then for the for the and then for the inner motorcycle, it's the same with Husqvarna, and Aprilia. For the Kawasaki, magically we have 4 respondents out of 42. So we divided 4 divided by 42 is equal to 0.0795. For the probability of Kawasaki event. For the KTM it's the same, and automatically the same, if you stay the same, just one respondents, then that, and then yeah, so the case the same. But for basically the 5 maps of this is the same. But for the Yamaha, we have 5 respondents, 5 out of 42. So we need to divide it by 5 divided by 42. So the sample space divided by the all of the sample space. So we get the result of 0.1189. So and but so in this don't have table, we define it as a student that don't have a motorcycles. Accidentally, the number of the student that don't have a motorcycle is the same with Honda motorcycle. So we just need to divide it by 42 also. We need to divide 7 by 42 also. And it's excluded brand. We don't have it on the list. The student uh, fill up the form itself using self 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 submit survey. So they so they input this brand tsunami. So this for the variance of the data. And now just one. So just need to divide by 1 divided by 2 and move to the probability function. All right. For the probability function, it's the same like it just need to send the effects, and then we just need to know I think it's probably the same, but we just need to change the effect because it's the function, not but not probability again. And then for the commutative distribution, it means that you need to add data one by one for the probability until it's 1. Why it's not 1? Because in the process we uh, we are stealing the results. So the result will be 0.7702 0.0. So you need to seal it. So we get this value. It was for counting the probability. That's why in the end of the data for the have tsunami is over than 1. It should be 1. In the real life it should be 1, but in our data, as you can see, it's more than 1. But just little because we don't count the exact value of the comma. We just round it up to the 3 number before after 0. Yeah. And then for the mean and reference value, we define value as 1 and Bernoulli as 2 and so on, and the tsunami is 19. So for this sample space, uh we defined it like this. We need to count it like 1 times the probability times 2 times probability times 3 probability, and so on until the probability is count. So the result is 10,050 10,582, and then this the calculation, the final calculation, and then for the mean, this is for the ES square for the mean square. The result is 100,045 to 262. So for the variance, we just need to subtract the EX square or the mean square with the no. I'm false. We need to subtract the mean value of the second of the mean square value with the mean value but square with square. So the result will be 30 30.28 and so on. I think it's all from us group K. Thank you for your attention. Uh, hope you are hope you are happy with our result and report and from the survey. Thank you very much.